Right, hi class. In this class, we're going to be looking at classes. We want to look at classes. We want to look at objects. We want to have an introduction to OOP, what it really stands for, and we're going to look at the characteristics of an OOP language, an object-oriented programming language. That is, we'll be looking at the pillars of OOP, which is abstraction, encapsulation, polymorphism, inheritance. Then we're going to dig a little bit deeper, looking at the different types of inheritance that we have in C#. Right. So a class basically is a collection of things which have what common properties. Right. For example, a person can be a class, and a class can have members. Right? The members of a class can be data fields, functions, constructors, destructors, properties, indexers, events. We are going to learn more about those things. Right? A property can also have, we talked about functions, and those are the contents of a class. You will find in other books, they will say that a class is a data type. Right? That is true. A class is a user-defined data type. In other words, we can also define a class as a blueprint for creating objects. You remember a blueprint when you are building houses, the blueprint of a house, those are the plans, the designs for a house. But the house is not actually the blueprint. The house is not the plan. I mean, the blueprint is not the actual house. But from the blueprint, we can then construct a house. So from the blueprint, which is a class, we can construct objects. Right? So in other words, an object is an instantiation of a class. We create objects from classes. In other words, objects, they are representations of classes. Objects are representations of classes. Right? So when you are writing your program, when you are defining a class, when you are declaring a class, you have to write first, you can write the access modifier. We are going to learn more about access modifier as we go deeper with the subject. Right. Right. So you start by writing the access modifier, and this is optional. You can choose not to write anything, because if you don't write anything, you get a default access modifier. Right. And then you write the keyword class in small caps. Then you write the class name, right? C# it uses different types of methods of declaring your variable or your class. So in this case, in C# we use a camel case. In camel case, we start with the capital letter, right? Every word starts with a capital letter, right? So this is how you declare a class. And then in object, I talked about an object. An object is a representation of a class. So if we go deeper with more examples, a class can be birds, right? Birds can be a class. And birds can have some characteristics such as having two legs. Birds have two legs, they have two wings, they have some color, they can fly, others cannot fly. Then we can create objects which represent birds, and these objects can be the actual different species of birds that we have. For example, a parrot, a woodpecker, an ostrich, a kiwi, a dodo, all those types of birds. Right. So now we want to look at the features of OOP, right? The features of OOP. The first feature that we have is abstraction. Abstraction is merely data hiding. It's the process of hiding the implementation details, right? Of the implementation details of a program, but providing the service, right? And this is fulfilled through the use of abstract classes. We are going to learn more about abstract classes in lessons that are to come. We fulfill abstraction using abstract classes and also using interfaces, We are going to learn about interfaces later. So basically, there are two types of abstraction. That is data abstraction and functional abstraction. We also have encapsulation. Encapsulation. We also have encapsulation. Right? Encapsulation is the process of binding the member variable of a class along with member functions. And this is implemented through the use of objects and access modifiers. Right? We are going to perform an example. I'm going to write a piece of code so that you see how the encapsulation actually works. We also have polymorphism. Right? Polymorphism. Right? Polymorphism, it's a word that is derived from a Greek word, right? Where poly means many, right? And morph means behaviors, right? So which means we can write a piece of code that can have many behaviors. It can be functions that can have more than one behavior. So there are different types of polymorphism. We have static polymorphism and dynamic polymorphism. Static polymorphism is also referred to as compile time polymorphism or early binding, while dynamic polymorphism is also referred to as runtime polymorphism or late binding. So we're going to see, as we do some more examples, we're going to see that static polymorphism is achieved using function overloading, function overloading, and function over and operator overloading. Whilst dynamic polymorphism is achieved by using function overriding. Function overriding as well. And then last but not least, we also have inheritance. Inheritance. So this is a process of creating a new class from an already existing class, right? So we can have a parent class and a child class. The child class will be created from the parent class. Therefore, it will inherit some features that will be existing in the parent class. For example, in our day-to-day lives, mwana anogona kuita dzinonzi nodzera handiti, right? A child can have some features. Can have his or her father's features. They can be eyes. They can have the same eyes. They can have the same voice. They can have the same skin tone. All those things. That's inheritance. So we can derive other classes from base classes. That's an example of inheritance. So we have different types of inheritance. That is inheritance. We have different types of inheritance. If you look at your syllabus, these are the inheritances that we have. Single inheritance, multiple inheritance, and hierarchical inheritance. These are the types of inheritance that we have. These inheritance. Right? So now we want to look at inheritance at a microscopic level. We want to understand what it really is and how it functions. So before we look at that, let's just look at the examples of classes. Right? Remember when I said C# is a pure object-oriented language, which means you cannot write any piece of code without implementing a class. Right? For example, this is the default code that comes when you create a Python project, right? As you can see, the class is called program. Yeah, it is C# convention to start the first letter of your class as a capital letter, right? So class is in small caps, and they did not give us the access modifier because it's optional. But if you see it like this, it means it has got a default access modifier, which is internal. Which is internal. It's internal. We're going to learn more about access modifiers. Right? Now, let me give you an example. this is a class, and in this class we have a function, right? We said a class can have a function, can have constructors, destructors, properties, indexers, and events, right? Let me create another function within this class. I want it to be public. So public, I don't want it to retain anything. So void, public void. Then I say hello, right? Then I need to write something. Console dot write line. Right, hi there. So this is just a greeting, right? So if I want to have access, to this function, I need to instantiate an object, right? If I want to have access to this function, I need to instantiate an object. Maybe before I do that, I just need to give you the syntax for writing a class. Sorry, for writing a function. Syntax for a function. Syntax for a function, right? Access modifier. Access modifier. Access modifier. Then return type. Then function name. Then you can have arguments in here. It can be optional. Then this becomes the body, right? You write here whatever you want to write in here. So you write your access modifier, you write your return type, then you write your function name. So as you can see here, this is the access modifier, this is the return type, this is the function name. Void means we are not returning anything. If we want to return an integer, we write int. If we want to return a string, we write string. If we want to return a character, we write char. So that's how we do it. So if you want to instantiate an object, instantiating an object, it's usually class name, then object name, equal sign, new keyword, then you write the class name again, then you terminate, right? This is how you instantiate an object. So in the next class, we're going to continue with this code. We're going to instantiate an object and see how it works.